All right, so for our main presentation, I want to welcome back Dr. Aaron Clevenson. He's been out here, he's been here at FBAC many times, so it's been over a year since he's been out here to give us a talk. And for tonight's talk, he's going to talk about the southern sky and the southern aurora. Now, we also have a guest online, Ann Barnes, who lives in Australia. And so I know she's interested in this, and she was also able to see the aurora. So Aaron also is director of the Insperity Observatory, which is in North Houston. So if you ever get a chance to go to the north side, you can stop by his observatory there. It's, I believe, open to the public. Is that correct, Aaron?
Once a month.
Once a month, okay. He's a computer guy. He has an advanced degree in computer science, artificial intelligence, and is also a past president of the North Houston Club. And Aaron is also involved with the Astronomical League, which will be the second part of our discussion. So without further ado, I want to welcome Aaron to give his presentation.
Okay, thank you. Hey, thank you. Good to see you all. I'm going to have to Zoom tonight. So I'm going to put I'm from Boston, so I'm going to put my Massachusetts hat on and talk really fast, because they're squeezing me into 30 minutes, which is unusual for me. Okay. All right, so the main reason for this presentation is a lot of us never had a chance to go south of the equator. That means we haven't seen the southern skies, and there's a lot of really cool stuff down there not to be missed. And I know you can rent time on telescopes, and that's a wonderful thing, but I'm a visual astronomer. There is nothing like actually experiencing it direct with your eyes. So I'm a little bit biased. So the main bottom line here is to encourage you all to go south. You got to go do this at least once. And I happen to be there during the May Aurora. We'll talk about that in the second part of the talk. Okay, so part one, the southern skies. So this is the technical part of the talk. And all of you realize my talks are not that technical usually, so this one will be no exception. Okay, so background, just for anyone who's not comfortable with all this, the Earth rotates, right? So that means when you're out there at night, you're not going to see the whole thing, because you're only going to see kind of what's opposite the sun. Because if it's near the sun, it's going to be blotted out by all the sunlight, so you won't get to see it. So, but over a course of a year, we get to see everything in all the different parts of the skies. But where we are in Houston, we're at 30 degrees north, and that means that bottom 30 degrees from an Earth perspective is stuff we can't see. It never comes above the horizon. And so there is a chunk down there that we can't see. We'll talk about it. And the exciting part of that is, if you go down there, a lot of it will be circumpolar, right? Because it's the bottom 30, just like the top 30 up here is circumpolar. So wonderful. Okay. I said that. I do want to just mention, it won't look like I did any, but don't forget to do sightseeing while you're down there. I mean, there's a lot of cool stuff to see as well. And if you're lucky, you might be able to see the Australia version of the Aurora Australis, so the auroras. In my case, it was New Zealand, but same idea. Okay, so let me just back up here. So we live in Houston, 30 degrees north. So the North Star is always at 30 degrees above the horizon. It also means, and I just actually realized this today for the first time, straight up is 30 degrees declination. And it makes sense. I just had not thought of that. But anyway, so at best, we're going to lose 30%. So if that, we don't get to see anymore. And just to elucidate a little bit more, if you're on the North Pole, your horizon would be the equator, the celestial equator, which means you're missing half the sky. And if you're on the equator, you pretty much can see the whole thing over the course of the year, except for the North Star, because it'll be right there on the horizon. You'll never see it. Okay, so that's why you want to go south. So this is Houston's latitude on this picture of the Earth. And of course, the Earth is tilted a little bit. And that's Houston's horizon. You know, it's just 90 degrees this way, 90 degrees that way, right? That's easy. Okay. And the red line is our spin axis. But we have this visibility limit down here, this blue line. We can't see stuff below that. And it looks like it's a very small piece. And it is. But there are some really cool things that are in that small piece. So let's look at the sky instead, because that's what we're interested in here. So again, same lines. This is what we can't see. So there's a lot of really cool stuff down there. And as I continue on, I'll mention some of them, and we'll talk about what my objectives were while I was down there. What did I just do? I don't know. We'll just keep going. So what are you missing? So there are some really cool objects. I've only got like 3 of them here. So one of them is the Coal Sack. It's a dark nebula. It's right next to the Southern Cross. And that's roughly what it looks like. And those 2 bright stars are actually part of the Southern Cross. So it's that close. Another one, and I'm going to have to move now. Another one is the Large Magellanic Cloud. So this is one of our satellite galaxies, so the Milky Way. And it's an impressive bit of clouds out there. You know, it looks like a star cloud. But it's a galaxy. It's an irregular galaxy, so it's not real exciting as far as, you know, having a fancy shape or anything like that. And then, of course, its little brother, the Small Magellanic Cloud, is also down there. So these are kind of the 3 main highlights. Those are the biggies. I will give you a bit of advice. If you do go down there, make sure you go somewhere very, very dark, because if you're in city lights, just like here, it washes out everything. So these were not impressive until we actually get into a dark sky preserve. So that's really important. Okay, so what else? Well, the Southern Cross. Now, just in case you don't know this, it's, if I get this right, this is north. So it's wrong side up. Well, turn it over. That star, the topmost star, the northernmost star, is visible from here. You have to time it right. You need a fairly good horizon on the south. I saw that from NHAC's dark site a long time ago. And I was inspired. I said, this is really cool. And I got looking at the charts, and these 2 also come above the horizon. But you have to have a perfect horizon. So I actually went down to High Island on the Gulf, sitting there looking out over the Gulf at the right date and the right time, and they were 1 degree above the horizon, which I guess probably means they're actually below the horizon, but that's okay. But so you can see those 3, but it's not the same thing, right? You got to see all 4. So you do have to go south to see that. So what else? Well, this club is part of the Astronomical League. The Astronomical League has a number of certifications you can work on. We were discussing it earlier. There's probably about 65 total right now. And these are the 5 that are southern sky oriented. So some of them are obvious. Southern Sky Binocular, and I'll run through them real quick. I think you have to observe 50. Southern Skies Telescope, I think it's 70. This is a new one. It's Bennett. It's kind of the southern equivalent of the Messiers. They can't see all the Messiers in the Southern Hemisphere. So we adopted that. That's a fairly recent one. Constellation Hunter Southern Skies, I'm kind of embarrassed by that. I wrote that observing program. And it took me years and years, maybe a decade, before I actually got a chance to go finish it. And then Caldwell, if you want to go after the Caldwells, probably about 30 of them are too far south to see. And so there's 109 total. You have to go south to get the gold version. And for those of you that are overachievers, we do have a Banbury 600 observing certificate. And if you're into that, it's only a certificate. But it's kind of like everything imaginable, soup to nuts, in the Southern Hemisphere. Okay, so you're going to go south. You got to plan your trip. So the first thing is, the further south you go, the better. And if you think about it, the same thing's true in the Northern Hemisphere. If you want to see northern stuff, the further north, the better. And of course, the inverse is also true. If you're too far north, you can't see anything south. But anyway, you want to pick a date when you have longer nights. So we went, and ours was in what would be their fall. And so the nights were getting longer. It also means they're getting colder. That was an issue. But you get more observing time that way. You know, the same thing's here. You know, during the summer, we don't start observing until 9 o'clock at night. Well, you know, that would be horrible if I had to do that while I was on this trip. And then you want to pick a destination with the darkest skies possible. I kind of mentioned that already. Okay, so where can you go? And I'm going to stand over here this time. So Australia, New Zealand, really good choice. South Africa, that's actually where the Bennett list came from. South America? Excellent, excellent. The problem is there's no real big cities down here, so you can't really go to the southern tip. But anywhere in here would be great. That's the Falkland Islands. So, and they speak English, which for me would be a big deal. Okay, so you want to pick a good place to go. And as I mentioned, we went to New Zealand. What are you going to take with you? And you all know this, at least any of you that have done much observing know. Well, first off, you need to have a planisphere. And yes, you know, we've got apps on our phones, and you can get planispheres off the internet, and that's all true. But nothing replaces having your own little planisphere, because you never know when you're going to need something and not have access to all those things. So that is the Southern Skies planisphere. It's a pink one. Red light, obviously, 10 by 50 binoculars, a small telescope. So if you're going to be doing some of these observing programs, some of them are manual. So you have to have a telescope that you can operate manually. Don't forget your logbook. And be sure to dress appropriately. And I'll explain why in a minute. Probably part of the Aurora discussion. And drink lots of water so you don't get dehydrated. Okay, normal stuff, right? Same thing you'd use to go anywhere. All right, so what did we do? Well, we went to Tahiti for a week and New Zealand for 2 weeks. And they bragged about Tahiti. Skies are always clear. Every night they were cloudy. The whole week we were there, except for about an hour, somewhere between 1 and 3 in the morning. And if you're going to be there from 1 to 3 in the morning, that means you have to check it periodically all night long, so you still don't get any sleep. You just don't get to do any observing. So the green X is where we were. I will also warn you, there is nothing to do on Tahiti except for sunbathing, swimming, and eating. That's it. We found a few other things to do, but really, that's largely all there was there. And there's not a whole lot of restaurants either, so you're a little bit limited. Then we went to New Zealand. This was, for me, the big deal on this trip. 44 degrees south is where we got down to. So if you want to think northwise, that's kind of the border between Canada and the US. It was wonderful. We were there for 2 weeks, mostly clear at night. I had one night that was so windy, the telescope was sitting there doing this. So it wasn't much good. But it was absolutely awesome. So they also speak English, sort of. So I recommend it highly. This was the view from where we stayed at the observatory. We stayed in a little lodge. Associated with it, that white-topped mountain there is Mount Cook. So absolutely gorgeous. All right, moving on. What happened? Constellation Hunter did it. Of course, you know, that's easy, right? Because you just observe, sketch, naked eye, no sweat. Southern Skies binoculars, another one that was no sweat. Very easy to do, bright objects. You know, it's kind of like our binocular ones. They're the best objects. So it worked really well. Southern Skies telescope, a little bit harder. But again, 70 and the list has way more than that on it. So another pretty easy one to do. And then they started getting tougher. The Caldwell Gold. So I had a bunch of Caldwells I had to do. And these were stressful. They were not as profound as I expected them to be. You know, I think Caldwell, Messier is kind of same category. And it was true for the northern ones. But when you get down to the southern ones, it also has some that weren't quite that bright and profound. Okay, anyway, so now I'll tell you. I went down there 3 weeks. My objective was to observe 259 objects. I observed 250 of them. And the other 9 were skipped intentionally because I can observe them from my observatory. So what the heck? But I completed everything except some of the Bennetts, which I thought, hey, that's pretty good. And skipped a bunch of dinners. I was with the family went off to dinner, and I said, well, I'll eat the leftovers when you're done because I want to observe. So I missed a number of dinners. Anyway, that's it. So that's, hopefully I've inspired you all. You're going to go sign up for some trip south. The place we went to was near Mount Cook. It was a lodge down there in the dark sky preserve. So we had really, really dark skies. I mean, they were gorgeous. And also had some other unexpected benefits, which we'll talk about as we go.
Question?
Oh, yes.
By any chance, when you were down there, was there a full moon or anything close to a full moon?
I don't remember it being a problem, so the answer must be no.
No, that wasn't. Not that it's a problem. We all know what kind of problem it is, right?
Well, right, but what I'm saying is I don't remember that being a problem for me.
Oh, yes.
Therefore, there must not have been a full moon.
Oh,
That is probably true. When we were picking the dates,
oh,
probably that was part of the consideration was let's do it when the full moon's not going to be there because I can observe the moon from here.
I just wanted to know if you happen to notice that it's upside down when you go down.
Orion is standing on his head. I did notice that.
Oh, the moon too.
Okay, so let's talk about the auroras. So you all know right now we are in a solar peak, right? Solar activity peak. Lots of sunspots, and they've been going on for a while now. And when you have more sunspots, you have more solar coronal. Yeah, come on, Aaron. Coronal mass ejections. And with that, you're likely to get more aurora. So let's talk about this. So again, for anyone who's not comfortable with this, what happens is it could be northern or southern, so aurora borealis or aurora australis. And what happens is charged particles from the sun in the solar wind, but in this case, even more intense because of the coronal mass ejections, come flying at the Earth. They interact with the Earth's atmosphere. And as they do, they give off light because they're interacting with some of the chemical elements. And we'll talk about those in just a minute. So as I said, it's every 11 years. If you miss this one, it's 11 years to the next one. I personally think it's going to go on for at least the first quarter of next year. So you probably have time still and yet. And you don't have to go south to see it. We actually have had two that were visible from Houston. I missed both. And north is cheaper and easier to get to than south. So there are places up north you can go to as well. Okay, so we are at or near the maximum. We'll skip that for now. Skip that. I sort of all said all that. All right. Yeah, we'll just move on. Okay, so it's an 11-year sunspot cycle. And as I said, we're at a peak now. So, 5 years from now, we'll be at a lull. I said that already, so I don't have to repeat some of this stuff. And the idea is when they come to Earth, they get caught up in our magnetic field, and they spiral around our magnetic field lines, and they head for a magnetic pole, north or south. And as they're doing that, that's when they come through the atmosphere. That's why Canada gets to see all of these and we don't, because they're much closer to the magnetic pole than we are. All right, so they get caught, blah, blah, blah. All right. And they interact with the Earth's atmosphere. We haven't gotten to the good part yet. All right, so this is a picture I took. And this picture shows the different colors. So I'm not going to go in the order they're shown up here. I'm going to start with the red ones, because red and green are the two most common ones. And the red ones are visible when you have lots of solar activity. So lots of charged particles coming in. They tend to be very high up, 150 miles up. So way up there. And they tend to interact with atomic oxygen. That's where the red comes from. The green ones down in the lower right-hand corner, also oxygen. And that's interesting because that's one of the forbidden lines of oxygen. Normally, we can't see those. In the laboratory, you can't see those. Anyway, from 60 to 150 miles up. So those are the two basic ones. But you can also have blues and purples. And the blues and purples are caused when those charged particles interact with nitrogen. And so now you got a different chemical element, you get different colors, and the arrows are supposed to be pointing to these. And then the yellows and pinks, they're not unique colors, they're combinations of other colors. So it's just, you're getting reds and greens, or you're getting reds and blues, whatever. But that's where those come from. So the thing here is you need a high level of activity to get most of these. The green one's fairly common. Okay. So what happens when the solar wind gets here to Earth? Well, the first thing is the aurora, right? We get to go see aurora. But it can also do other nasty things. So one of those is if you're a spacecraft, you're out there, you're a lot more exposed than us on Earth because we're a little bit protected by our magnetic field. So they actually shut spacecraft down because when those charged particles hit the spacecraft, it energizes all kinds of stuff. and it'll short stuff out and burn it up, and you don't want that happening. So you shut it off, ride through the storm, and then you can turn it back on, and hopefully it'll be perfectly fine. Same thing is true for people out there. So we got folks in the space station. Now, they're actually fairly close to Earth. They're well within the Van Allen radiation belts, but they're still much more exposed than we are. And so they do have a safe room where they can go hide, you know. I don't know all the details. But anyway, but they do have a way to do that. And it has caused major problems here on Earth. We've had blackouts, you know, major blackouts where, oops, you know, it comes in, it charges, it overloads stuff, blows all kinds of stuff apart, and now you've got a power outage. So serious consequences, some nice pretty stuff to look at, but you don't want it to get carried away. So what does this look like? So if you go out to a website called spaceweather.com, it offers a whole bunch of information, more than you could ever possibly want. One of them is it does show what the auroral oval forecast looks like. Green is minor. And you can see the scale there. Green is on the left. I guess it's something even darker than green. Red is on the right. Red are the really good ones. That's the ones we want from a visual standpoint. And it tends to be stronger on the dark side of the Earth. So if you look at the one over there for North America, well, Northern Hemisphere, you'll notice we're in daylight in that picture, and the higher intensities are on the far side because at night. Okay, so this is what normal looks like. If you went out and looked today, in fact, I did look today, it's a little less intense than that, but basically that's what it looks like. All right, so if we're going to go out there, what might we see? Well, we might see draperies. These are the really fancy ones that people love because they sit there and they ripple and, oh, all kinds of really cool stuff. You might see an arc. I've never seen one of those. That's kind of impressive, though. You might see a diffuse aurora, or you may see rays, or a combination of all of these. However, I need to warn you, if you go out there and look with your eyes, you may not see anything. And the reason for that is they're usually not bright enough to kick off your cones in your eyes, the color cones. That means only your rods can pick it up, black and white, so they're going to appear different shades of gray. Get your camera out, even if it's the one on your cell phone, take a picture of it, and all the colors magically show up. So, you know, I mentioned we saw it. We saw some really cool aurora, but they were gray. I mean, yeah. All right, but you get the camera out, now they're impressive. Okay, oh, and there was one more, corona, sorry. I forgot there's a fifth one. Okay, so a few more things to warn you about. They come and go. So if you go out and look, and you don't see anything even with your phone, nothing's happening, you should wait, because an hour later, it may be even better. And if you use the predictions, if they say this is a big deal, chances are there's going to be some really good auroras to go with it. I mentioned a bit about the rods and cones, so I can skip that. Light pollution, ooh, bad, bad, bad. So I can't even, because I haven't done it, I can't even imagine doing it from Houston or up at my observatory, because we have so much light pollution, it washes out everything in the sky. And on top of that, because we're so far south, it's going to be low on the horizon. So that means I have to go somewhere where I've got a really good northern horizon if I want to see it. And then, of course, the absolute killer of all of it is weather, which is always unpredictable at best. All right. So more stuff off of the solar website is they have a KP index. And I'm not even going to try to pronounce that, but that's the guy it's named after. Anyway, it tells you the effect of all of these charged particles getting to the Earth and what it's doing to our magnetic field. And so you can go out there, you can check this. It's in the past, so it will not show you what it's doing right now. It'll show you what it was doing 3 hours ago. But if it's been going up all day, it's probably still going up, so it should be even better while you're out there. The range is from 0 to 9. 9 is the strongest. They put a little asterisk over it if it goes above 9 because it went off the top of the scale, you know. Okay. And it's an average weight, 13 different ground stations averaged in 3-hour intervals. So remember, things are short, so it must be really intense if it's going to pick it up with a 3-hour average. Okay, and here's what they mean. The really good stuff is down here near the bottom. And this is how often you can expect to see it in a solar cycle. So remember, a solar cycle is 11 years long. So 900 days, that's about 3 years, right? Not bad. But as you go further down here, they get more and more intense. You're lucky if you get 4 per solar cycle of the really intense ones. So far, we've actually had 3. So that's pretty intense for this time around. And those are the ones that you want to see because those are the ones that are going to be most profound. Okay, so how to make this as successful as possible? Well, number one, you want to make sure you're there for the peak of the cycle, right? You want to be there now. You want there to be a high level of solar activity. They can't predict it more than a few days out, but you know, you can tell if there are big sunspots and they're starting to come around the sun in the part you can see, then there's a good chance that they will have coronal mass ejections. Some of them might head towards Earth, and then we get to see auroras. Weather, enough said on that. Okay, the closer you are to the magnetic pole, the better in general. If it's a really intense storm, it's not necessarily that important to be that close. But for most of the aurora that you're going to want to see, you want to be up fairly close. So that amounts to being in the right place. And then, Northern Hemisphere is better than the Southern Hemisphere. Now, that's a little bit misleading. It really isn't, but there are more population areas, therefore more airports, therefore it's easier to get to in the Northern Hemisphere than it is the Southern Hemisphere. That's the only reason it's better. So that's misleading. Okay, and you want to make sure you go during the best season. So for us up here, it's September through March. Southern Hemisphere, obviously, is the opposite, right? March through September. And that's because those are when you're going to have the longer nights. And so you get more opportunities. More success factors. So I mentioned they were short duration, so this is where the right time comes in. So right place and right time. You want to make sure you're there. Obviously, it has to be at night, darkness. It'd be real scary if you could see them during the day. That might be, you know, the end of the world as we know it. Okay, anyway, and then there's a value out there that they use called BZ or BZ, if you prefer. And that value tells you how likely it is for there to be auroras, and it has to be negative. So, you know, you can look on that same site, spaceweather.com. It'll tell you what the BZ value is, and if it's negative, that's a good sign. And it has to do with the orientation of the incoming charged particles. And if it's not oriented right, it doesn't interact with the magnetic field like it should. Okay, so negative is better. And again, no light pollution. So you want to get as far away from civilization as you can. All right, so in May, there was a peak. I'm going to use 2 different days interchangeably. It's the same event. So if I remember correctly, for here it was May 10th. For there, it was May 11th. On the other side of the date line, right? Okay, so that's why I'm going to just use them interchangeably. We're not going to worry about whether I'm correct or not. So this is what the sun looked like. And these sunspots are moving from this side to this side. And take a look at that sunspot. That is just absolutely incredible. And it can shoot them straight at us when it's dead center. Okay, so the sun rotates about 30 days. That means we get to see a sunspot for about 15 days. That means one side of the sun is about 7 or 8 days. That means it's halfway over, so that was 3 or 4 days after it happened to be dead center. So if it's dead center, that's when it's going to shoot us. And by the time they get here, it should be over here somewhere. All right, so that kind of looks like perfect placement. Okay, and then I want you to take a look at this. Can we turn off one of these lights? Possibly. Because there are some things you're going to want to see, and you don't need to see me. So, oh, much better. Thank you. All right, so take a look at this. And I'll just be quiet. Every one of those things that puff off are solar mass ejections. Coronal mass ejections, excuse me. And it should run it twice. Yeah. Now, it depends on who you, by the way, that's Venus and Mercury were the two planets. And we can leave the lights off because I got one that's going to need dark even more. Depends on who you ask. If you ask my wife, she'll say it's 4. If you ask me, I say 5. According to NASA, it was 9 coronal mass ejections. And if you look in that picture I just showed you, it's time-lapse, obviously. But if you look in that, there's probably at least 7 that were captured in that little segment. What happened in this particular case on this particular date is all of these ejections happened, and they travel at different speeds. Some are faster, some are slower. They get here anywhere from 2.5 to 6 days after they leave the sun. What happened in this case is all 9 of those piled up on top of each other before they hit the Earth. Okay, so kind of a really rare, bizarre set of circumstances. And this is what that diagram looked like. So you can see they were predicting, oh yeah, big time. And although this has not made it down to Texas yet, it did, because this one would have been visible here. The problem was timing. It happened during the day. So it would not have been good. But you can see it is having trouble here. All right, it is working its way down. If you look at this timing-wise, it looks like New Zealand got nothing. But remember, this is daylight. So by the time night got there, this was over here. So yeah, it was pretty impressive.
So that red ring does not rotate with the Earth.
The Earth rotates under it.
Right, Roger. Thank you.
Nobody has asked me that. I had to think about it before I could say that, but yeah. All right, so what was going on? Well, this is the other chart that I like. These are the KP indexes for 3 weeks. And the week in question is here. That was the week before. This is the week after. And I'm not ready to say it yet, so I'll save that for a minute. And you've got to realize they're 12 hours out from Greenwich Mean Time. So where this says 12 to 15, which would be noon, it's actually 12 to 15 midnight. Okay, so that was what we were looking at. There was a maximum, and we're going to do these New Zealand time, at 3 a.m. on the 10th there. I didn't actually see the peak of that one. However, the following night, there was another one that happened at local time, 9 p.m. And we just happened to be observing 9 to midnight, more or less. Okay, so let's take a look at what this looked like. Oh, wrong button. Okay, there those are. That's wonderful. All right, so this is where we were. We were down here near Mount Cook. We were at a lodge that had an observatory. And what you've got to picture is we made these arrangements 9 months in advance. We had no clue that there was going to be an aurora. And my agreement with my family was, okay, I'm going on this trip with y'all, but we're going to spend 3 days at the observatory because I want to observe. And so I even made arrangements with the observatory to basically rent their telescope with an astronomer for 2 hours after a star party that we all went to. And I said, this is fine. I don't mind paying for you. And yes, you can be here, but I have to drive. Right? These are certifications. I have to do it myself. I can't have somebody do it for me. And so they agreed to all that. We get into the observatory, and it was cold. It was 32 degrees Fahrenheit inside the observatory. And so both the astronomer and I decided it's way too cold to spend 2 more hours out here. So we just canceled that part of it. We did the star party. And the interesting thing about this was, it dawned on me, I've been observing 2.5 weeks in southern skies. I probably could do the star party. But I decided, now this would be good. I want to hear what he does because everybody's different. So it's always fun to hear somebody else doing it. Anyway, so we're Mount Cook, Lakeside Retreat, wonderful place. It's on Lake Pukaki, which it's got to be one of those. But I don't know. I'm thinking it's this one, but I don't know. Anyway, it is in the International Dark Sky Preserve. That's that purple area on that chart. And it was wonderful. Supposedly, they had a 9.25 celestron. It wasn't a celestron when we were there. It was, if I had to guess, I would say it was probably a 5-inch refractor. Didn't look like a celestron at all. More on that in a minute. But anyway, there were 4 of us plus 2 astronomers. We had the place to ourselves. Nobody else had signed up for that night. And if I ever build my own observatory, my own personal observatory, I'm going to do what they did. It was connected to their wine cellar. You walk in and the astronomer says, red or white? And if you say, no, I'm not into wine, he says, we also have whiskey. And if you say, no, I don't want whiskey, which this night we didn't, they had hot chocolate. And I think we drank them out of hot chocolate because it was so cold. Anyway, that's the way to do it, though. Connect it to your wine cellar. File that away for when you build your future observatory. Okay. So what about timing? So we're in the right place. We started at 8:30. We ended at 10:30. The skies were absolutely crystal clear. Again, that is my picture. Temperature was 32 degrees. So you do want to dress warmly. The aurora was so profound and so bright that at one point during the peak, we had pillars of light coming up from all horizons, all the way around us, meeting overhead. It was red overhead. Absolutely incredible. In fact, that's what that says. And as my little red note down here in the corner says, it was all pure dumb luck.
Did they just look gray, naked eye?
Yes, which is so depressing, but yes. At least I didn't see. Did you see any color?
I thought I was seeing,
I'm probably a little more critical than the rest of my family would have been, but I didn't notice it, which was disappointing, but the cameras picked it up. No problems at all. Okay, so how did we do? Right place, right time. Peak of the 11-year cycle, check. 9 successive coronal mass ejections, not that I asked for that, but check. Perfectly clear skies, check. What happened to my, what's going on here? Going backwards. Southern New Zealand, right? Got to go as far south as you can. 44 south is, this controller and I are not getting along very well. Okay, we did that. The right time, it was mid-May, so that was during their better season. So check that one off. We were there on the day of the peak, now we're at the right time, right? So we were there day of the peak, check. Time of the peak, check. So I think we're doing really good here, and of course it was at night, so that one gets checked off too. So I think we kind of hit a home run. It was absolutely wonderful. Like I said, it was just luck, but we got to see it. Oh, and then I went and got this one after the fact. The BZ was minus 46 nanoteslas, which is pretty far negative. So that was, perfect. So that one gets a check mark too. Oh, it keeps going. Plus we were in a dark sky preserve, so that one gets checked too. Okay, so I was very pleased. I was very happy. And again, I got to emphasize this is just pure dumb luck. Okay, this is it. I'm going to make sure I'm completely out of the way because I don't want you to miss this. So now, the truth in advertising. I did not take these pictures. They were taken by one of the astronomers. His name was Benny Wang, a young guy. Had a SLR set up on a tripod, taking one picture every 5 seconds. And this is what he got while we were sitting there looking at it. But you can see how it comes and goes. And really comes. So that was over the course of a couple hours. Okay. Yeah, it was. And it's kind of sad. Experiencing technical difficulty again. Okay, I'll talk about this in a minute. It's kind of sad. I had all these plans. I want to go see the Northern Lights. So Barbara and I have been sitting here planning, talking about, well, we could go here, we go here. I've been to Fairbanks. It was cloudy the whole time I was there, so I didn't see one bit of an aurora. So that was a dud. So I was saying, well, we can go to Churchill, Manitoba, They have Aurora 300 out of 365 days a year. Sounds like a good bet. We can go to Iceland. We can go take the cruise up the coast of Norway. Those all sound like really good plans. And I saw this, and the 9 coronal mass ejections, and it's spoiled. You know, all those vacations are now, forget it, why bother? So, might be worth going for the scenery, but I no longer have to go see an aurora. Okay, so I have a little bit of a wisdom from a crazy old astronomer. That would be me. The first one is observe, observe, observe. And the reason for that is there are rare moments in life, and pun is intended here, when the stars align, that you want to be out there, because if you're not, you'll miss it. So if you're watching TV or surfing on the internet, then you're going to miss the good stuff. And this was one of those cases. We were out there just observing, and it was actually so bright, we couldn't see the stars. We grabbed the chairs and went out and sat in the field and watched the aurora. Okay. So I mentioned, you know, sometimes the stars aligned. I've had 2 in my life. The first one was back in 2002 for the Leonid meteor storm. You know, we knew it was going to be a meteor shower, and they do absolutely horrible predicting meteor storms. So, I mean, it's nice that they think it's going to happen, and my experience has been almost never does. Well, anyway, so we were up at the NHAG dark site. This was 2 sites ago, so a long time ago. And we estimated there were 1,435 meteors per hour. Only lasted 15 minutes at that intensity. And it's an estimate because no way you could count those. But they were everywhere. They're kind of like those woodblock prints that you see where they, you know, captured meteor storms in the past, and they're everywhere. Well, it was just like that. And then, of course, the other one is the Aurora in May. And that's it. And I've been observing for 35, 40 years. That's really sad. But you got to be in the right place and at the right time, and that means you got to be out there observing every chance you get. Okay. And that's it. So hopefully I'm well within my time limit. No? Sorry, guys. I went as fast as I could. So let's put the questions off, if that's all right with you, Mr. Moderator. Okay. Then I will.
We'll take a 5-minute break.
What time is it? Thank you.